Hello, I'm solving the climbing stairs today. Let's read the problem. You're climbing a staircase. It takes n steps to reach the top. Each time, you can either climb one or two steps. And how many distinct ways can you climb to the top? Note, given n will be positive integer. Let's see the first example. Input is 2. And then the output would be 2 because there are one step plus one step, and the other way is two steps. Second example, the input is 3 and the output is also 3. That are the 1 plus 1 plus 1 and the 1 plus 2 and the 2 plus 1. Okay, let's think about how to solve this problem. Let's see. You can first draw the binary tree, showing the distinct ways of climbing stairs. Left child would be one step, right child would be two steps. So the every combination could be shown using the binary tree like this. So the every path reaching n could be included in the summation of all distinct ways. We can implement the searching tree function using the recursive calling. Let's see the climb function. With position parameter, we see indicates the current location of the stairs, size the n. This function is recursively called with pos plus 1 and pos plus 2. The pos plus 1 means the left child, and the pos plus 2 means the right child, and the binary tree. And pos reaches n, this function returns 1. At this point, the current position would be the leaf node in the binary tree, so the return 1 would be counted as a single path from the root node. And we can store the intermediate summation values to reuse it without the repetition of calling the recursive function. This is called memoization. I implemented this climb function. It's exactly the same as the pseudocode except one line. I added if pos is bigger than n, this function just returns 0 because this path doesn't satisfy reaching place n. Okay, let's see the binary searching tree with the n value 5. I want to explain the relationship of n and its answer. If n is 1, the distinguished path number is 1. And if n is 2, the distinguished path number is 2. And if n is 5, the distinguished path number is 8. So if the n value is 1, 2, 3, 4, 5, the answer is 1, 2, 3, 5, 8, respectively. So this relationship is the same as the Fibonacci number array. The next number is the summation of the previous two numbers. With this pattern, we can implement the solution. dpi is assigned by dpi-1 plus dpi-2. This is called the recurrence equation in the dynamic programming. dp is the array storing the interim results to finally get the answer by accumulating the interim answers, and finally returns the dpn. This solution's time complexity is on, actually same as the previous recursive solution using the memoization, but this solution is faster than the previous solution by using the for loop instead of a recursive function call. Improved solution is just using 3 local variables, temp, first, second, because each element of dp array is just used for each calculation and not used later anymore. So we don't use to use array to accumulate the intermediate results. So this solution is fastest and least at its memory usage. Okay, thank you for watching. See you. Bye bye.